Yes, children, let's talk about the glomerular and aglomerular kidney, right? So, right, where is that? Yeah, now let us see this. So this you can see is salt, this is fresh water, and on the other hand you have marine water. So there are two types of water here, water presence and water availability. So in marine waters there is so much of water present, but it is no way useful for drinking. So fresh water has more drinkable water, while marine water has less drinkable water. Based on that, fresh water has more water and marine water has less good water. Now the freshwater fish, comparatively has less water than the fresh water. The marine water fish has comparatively more water than the fresh water. Now let's talk about the salts. So salts are more in the freshwater fish compared to the water. On the other hand, salts are more in the marine water compared to the fish. Now tell me, water always travels from a higher to lower concentration. So in the freshwater fishes, water is taken into the body, while in marine water fishes water comes out. So when water is coming into the fish, it is endosmosis, that's a problem. And on the other hand, when water is coming out of the fish, it is exosmosis, right? Both are problems. What about the salt? The salt will get out of the freshwater fish, so salt loss. Now on the other hand, the salt will come into the marine water fish, so it is salt gain. So what is the remedy now? So if you are the freshwater fish, you have to gain salts because you already lost, and if you are a marine water fish, you have to lose salts because you have already gained salts. Now freshwater fishes, because they are losing the salts, they definitely have salt absorbing cells, and marine water fishes, because they are already gaining the salt, they should excrete the extra salt, so they have salt excreting cells, right? So these cells are present in the gills of the fish. They are called chloride cells. Now at higher altitudes, let us see. At higher altitudes, for example, in Rotang Pass near Manali and Mansarovar in Tibet, which are at more than 3,500 meters altitudes, the atmospheric pressure definitely comes down as you go up. At the same time, the partial pressure of oxygen also drops down. So as soon as partial pressure of the oxygen drops down, the person suffers from mountain sickness or altitude sickness. What are the symptoms? FAN are the symptoms: fatigue, abnormal heart rate meaning fast, and nausea. And how does the person adapt to this mountain sickness? There is more RBC production and there is more breathing rate at the same time. This is very important, children. The hemoglobin's affinity for oxygen is reduced. Now the job of hemoglobin is to carry oxygen to the tissues. I imagine this bond is so very strong. Do you think hemoglobin will leave oxygen? It will not. So for this reason, hemoglobin's affinity for oxygen is made very less, so that oxygen is very soon given to the tissue. So hemoglobin's affinity for oxygen is reduced, and so oxygen is delivered to the tissues, right? Then plant adaptations in water scarcity. If you can see here, these plants which are in water scarcity, definitely they must be xerophytes, right? You must have learnt in botany. So xerophytes, they have a thick cuticle. The stomata are present in deep pits and they exhibit CAM pathway, crustacean acid metabolism pathway. In this pathway, stomata are closed in the daytime while they are open in the night time for photosynthesis. For the transpiration. Now these all three features, they reduce water loss through transpiration. Now in Opuntia, the cactus, leaves are reduced to spines, while stems take the job of leaves, which is photosynthesis. Now animal adaptations to water. We learned the temperature, now to water. Let's take kangaroo rat. So rat is a mammal. We learned in Param, aves and mammals are warm blooded, while PAR are cold blooded. So rats belong to mammals. So these rats can maintain their homeostasis. How do they do that? So this rat is basically present in North American desert, and how does it adapt to face the water scarcity? It has two adaptations. Number one, kidney. The kidney has very long loop of Henle. The longer the loop of Henle, the more concentrated is the urine. And kangaroo rat also exhibits internal oxidation of fat. So this oxidation is also called beta oxidation. So as fat is being oxidized, the byproduct is water. It means this kangaroo rat is making this water, so this water is called metabolic water. This is how it has its own water. Though it doesn't have water to drink, it can make its water. Now life history variations. Let's see this. Some organisms breed only one time in their life, while some organisms breed many times. So these one-time breeders are called semelparous, semel meaning once, and these many-time breeders are called heteroparous, hetero means second time. In botanical terms, monocarpic and polycarpic. And what are the examples? Now what is that? Oh my God, yeah. For one-time breeders, you have BP. Where is that? So one-time breeders OBP, one-time breeders bamboo and pelagic fish. And for many-time breeders, you have MBM, many times. This is birds and this is mammals, right? Now still, if you go down and see, some organisms produce offsprings which are small but many, and in the other case some organisms produce offsprings that are big but few. So these are small offsprings like this and many, and these are big offsprings and only few. So small but many, you have oysters and pelagic fish, and big but few you have birds and mammals. So BBM here, SOP here. If you can see, birds and mammals are common here and also here. So birds and mammals are many-time breeders. If you can see, birds and mammals are many-time breeders, and they produce big but few offsprings. One best example is ostrich, other example is you and I. Now there are two types of selections, R selection, R is small here, K selection, K is big here. Now what's the difference between the two? What do you mean by R? R is intrinsic rate of natural increase, right? So the more the R is, the more the organism is fit. That is what Darwin has said. So Darwin says a fitness, according to him, is reproductive fitness. So reproductive fitness is otherwise R. Now come on, tell me, look at this, these two examples. Which of these two parents have more R? Is it the parent which is producing small but many, or the parent which is producing big but few? Definitely consider this many and few here. So many offsprings, irrespective of the size, many offsprings the R is more. So few offsprings the R is less. So let's see this. Now the two types of selections, R and K. So environment for R is unstable, so it has to produce many offsprings. And for K organisms, the environment is stable, and so they produce few organisms. Then maturity of the offsprings is early this side and late this side. Because it is early, obviously growth rate is fast, and the other side growth rate is slow. And the parent requires energy to make the offspring. In our selection, the parent expends less energy, and so the offspring is called cheap. On the other case, the parent has to expend more energy to make the offspring, and so they are called costly offsprings. And coming to the reproductive fitness, obviously these are many, and so the R is more, and these are few, and so the R is less. Let's talk about the growth models. So, two types of growth models we learnt already in NCERT, exponential and logistic. Now, let's talk about these differences here. In exponential, resources are unlimited. Obviously, there is no competition. On the contrary, logistic growth model, the resources are limited. Of course, there will be competition. So, which of these two is realistic? Yes, logistic is realistic, because hardly we see unlimited resources, right? We are always exposed to limited resources and more competition. And in a day or two, you are also ready for the competition, NEET exam. Now, the other name for exponential is geometric growth, while that for logistic is Verhelst-Perl growth, otherwise called arithmetic growth. And the curve here is J-shaped, on the other side it is sigmoid. And let's see the formula. For exponential, it is dn by dt. What is dn? The difference between the initial population and the present population, and dt refers to the time, initial time and the present time. Now, dn by dt is equal to birth minus death into n. So, birth minus death is otherwise called r. So, you can replace b minus d by r. So, dn by dt is equal to rn. On the other hand, if it is sigmoid also, it is the same equation, dn by dt is equal to rn. But what specially happens here? We just learned that there is limitation in resources, right? So, that limitation resources is otherwise here called k. You can see here, what is k here? K is called the carrying capacity, beyond which organisms cannot anymore grow. So, this Rn into k minus n by k. So, k minus n by k refers to environmental resistance. Now, you can this k numerator and denominator is common. So, let us pull the k out. So, the equation becomes the same. dn by dt is equal to Rn into, instead of k minus 1 n by k, let us write 1 minus n by k. This is very important now. Now, for some reason, let us say n is equal to k. So, let us say n is 2. So, k is also 2. So, 2 by 2 is 1. So, 1 minus 1 becomes 0. So, whenever n is equal to k, r value is 0. Recent, I think 2018 NEET question. So when there is no growth rate, you call it a stable. Stable is otherwise called asymptote. Now n is less than k. Let us say n is 2 and k is let us say 4. So what will be the answer? It is 0.5, right? So 1 minus 0.5 is still positive value. So when n is less than k, r is positive. Obviously when n is more than k, r is negative. I wrote here, you can see here, when n is n is equal to k is otherwise n by k is equal to 1, right? The same thing I wrote here, you can check it later on. Now this is given in the NCERT, the R value for different 3 types of animals here. Norway red, the R value is 0.015, floor beetle is 0.12, human population in India 1981, 2 years before I was born, 0.0205. I am 37 right now, right? Now look at this curve here. So you have the x and the y axis, and this is a J-shaped curve, if you can see, the A exponential curve, and the other one is the sigmoid pattern. This is B, the logistic growth model. So logistic, this growth is stabilized when it meets k, if you can see. This is stabilized when it meets k, and so this is our logistic growth model. Now population attributes. Now let us see natality is otherwise birth rate. Let's say initially there were 20 frogs and 8 new are added. So birth rate becomes new by old, which is 0.4 offsprings per frog per year. Now mortality is death rate. Let's say initially there are 40 fruit flies. Now 4 fruit flies are dead. And so death rate is new by old, 4 by 40, which is 0.1 death per fruit fly per week. Then let's talk about migration. There are 2 types of migrations, immigration and emigration. Let's say India here, and this is USA. Now you are going to USA. So with respect to USA, you are an immigrant. With respect to India, you are emigrant. So immigration is adding to the population density, where emigration is not adding to the population density. Now remember this very important point. In a newly colonizing population, the increase in population density is mostly because of immigration, because it takes time for us to reproduce. By then till then immigration takes over the job. Now this is population density. Immigration and natality add up to the population, while emigration and mortality, they will decrease population density. Now sex ratio. So let us say this is female are 60%, males are 40. You can say the ratio of female is to male is 3:2. Now age distribution, we have age pyramids, pre-reproductive, reproductive and post-reproductive. Now if you can see this here, A is pre, B is reproductive, C is post. Now if pre-reproductive people are more than reproductive and reproductive are more than post, it is triangle, it is growing population. Now if you can say A and B are same and more than C, this is bell shaped and stable population. And if you can see reproductive is more than A and C, it is urn shaped or bulb shaped, it is declining. Very important, declining you have urn shaped, stable pyramid we have bell shaped like this, and growing you have triangular, growing population triangular. The population interactions, let us see. We have 6 types of interactions. Mutualism, both the partners are benefited. Commensalism, competition, both are harmed. Predation, one is benefited, other is harmed. Parasitism, one is benefited, other is harmed. Amensalism, one is harmed, other has neither benefit nor harm. Commensalism, one partner is benefited while the other is neither benefited nor harmed. Now symbiosis is very important, you have to make a note here children. Symbiosis is living together, whether both the partners are mutualistic or one is zero, one is getting the benefit, one is not getting the benefit, one is neutral, one is getting the benefit and one is not. So these are all symbiosis. In symbiosis, the 2 partners live together. While amensalism, predation, parasitism, these 3 are also symbiosis, but they are very, very closely present. So interacting species are very close together in amensalism, predation, parasitism. A, P. A for amensalism, P for predation and parasitism. You have to keep in mind children, symbiosis is the phenomenon wherein 2 organisms, 2 partners live together. They can live together happily, or one can harm the other, or one is neutral, other is benefited, one is neutral, other is harmed. But anyways, amensalism, predation and parasitism, these are the 3 interactions wherein the species are very, very, very closely present together. Let's talk about the rest in detail in the next video. Thanks for your time. Bye.